Almost immediately after going 2-0 at Kilobots Nationals 2019 with the original Blastwave, I got to work on designing a new version. If you haven't seen the video where I go through the initial CAD design, I highly recommend watching that before continuing on. The link should be up in the corner along with the description. I'm Caden here with Kepler Electronics, and let's get started. Let's start with all the changes that were made to the CAD after that initial video. I originally had two revisions of the chassis CAD, one which was slightly longer to allow for bigger wheels, and one which was slightly shorter. I ended up continuing on with the shorter one. It's been a while since I made that decision, but I'm pretty sure it was because I wanted to try and keep everything as compact as possible. However, the short revision was still heavily modified from where I was in the initial video. The original, shorter version was brought up to the standards of the longer revision, with the switch placement moved to the back for easier access and easier printing, and these little angle bits were added to prevent the bot from tipping forward and letting the impactors hit the ground. However, these were not the only modifications, as the bearing supports were thickened up to fully encapsulate the bearings, at the suggestion of Skarosaki and Tweety on the Out of the Arena Discord. Thanks for that. They also press fit inside, so the bolt is really only there for big hits. I also ended up carving away a bit from the front lid supports, as the impactors could hit these, so I just removed this small arc of material. I also went ahead with another small modification that I had hinted at in the initial video, and added a small indent to the motor mounts, both for a slight bit of retention and because I thickened up the entire chassis to 5mm, and I wanted to get more of the motor shaft out for the wheel hubs to grip onto. There are a couple more modifications I might pursue, like changing the lid screws over to threaded inserts, which would necessitate modifications to the screw posts. But I think that would be a good idea. It's super easy to thread the current screws in at an angle and have the head drag on the floor. And the inserts seem to work well enough in Thwackintosh, but we'll have to see. One of the first parts of the bot to actually be made were the lids. I'd initially planned on running titanium, similarly to StompBot 2, but as with StompBot, I went ahead with cheap sheet metal from a local hardware store. This was initially just because I didn't think my drill bits and saws could cut titanium, and I didn't want to waste my one sheet, but I ended up just going with it. I also don't think this design is running anywhere close to the weight limit, so who knows, I might just save it for whatever build I start on next. Either way, I did cut this on a bandsaw, which I guess ended up ruining the blade. RIP. It still worked alright, though I will use a grinder for the next set. Now that the lids have been made, I wanted to paint everything. I'm also painting the chassis, as I do care about the aesthetics of the bot and want the lids to color match with the body. Another big change from Blastwave 1 is that I now have access to a full lathe, which is pretty awesome, especially seeing as the local makerspace closed down. The first drum was made from the same stock as Blastwave version 1 by my brother and a resident lathe expert. This was much smaller than I wanted, so I ended up buying some smaller stock and giving it a go myself. The process is pretty simple. Cut the rod to length, chuck it on the lathe, clean up the edges, use a stepless tapered drill bit to get a nice hole in the center before popping on a drill bit that's slightly wider than 5mm. This is to allow clearance for the shaft. After some potentially cringeworthy accidents, be careful to not overextend the drill holder and always be safe when using a lathe, the hole goes completely through and I can then move on to the pulley. I wasn't skilled enough to get it completely centered, but I guess the motor isn't perfectly centered anyways. The bar was then transferred to the drill press, where I basically destroyed the first one by moving the drum, resulting in the holes not aligning. I also destroyed the second one by allowing the screw heads to extend over the pulley channel. I did manage to nail the third one by being super careful to keep everything in line and not take the drum out of the vise, as it is incredibly difficult to get the holes facing directly upwards again. I would recommend adding some small wood piece or something underneath, as it is super easy to drill into the vise, as evidenced by me drilling into the vise several times. But after 2 failures, the third time was the charm, and I produced this great drum. All of the holes are in line, the screws aren't encroaching too close to the pulley channel, it's great. Speaking of the screws, they are 1/4 inch, the same size as the original Blastwave. However, the impactor arrangement is different, where the screws are arranged in this sort of offset fashion. I go into a bit more depth about this in the CAD video, but suffice it to say this should provide better bite into opposing robots. Comparing it to the original drums, it is shorter for sure, but it is thicker. It does come in at about 19 grams lighter than the original drum though. However, a lot of that extra weight can be attributed to the extra impactors and their extra length. Not to mention the steel shaft sitting in the center of the drum, glued in place with thread locker. The new drum does have this greater diameter, and with the fewer impactors, they should be able to get a better bite than the original Blastwave. I will for sure be preparing several of these drums for the next competition, thanks in large part to destroying 2 of them in the first competition. one by taking weapon on weapon hits, and the aforementioned thread locker preventing the drum from being put into a new chassis. The only other part that was custom manufactured was the motor spacer. This was to hopefully prevent the plastic from melting like it did on the first revision. This ended up being too hard to make on the cheapo drill press, so this was replaced with some aluminum spacers and washers. With the lids, chassis, spacers, and drum completed, it was time to move on to the electronics. Let's start with the speed controllers. I was originally planning on the Venndaction DESC with integrated receiver, but due to its cost, I decided to roll with some of these. Dual speed controllers that connect to an external receiver. Not quite sure who makes these, they were purchased from our corporate overlords at Amazon, but they are a lot more affordable for my poor student wallet. As mentioned before, they don't have a built-in receiver, so that necessitated searching for a new solution. Venndaction was sold out of their Lemon RX receivers, so I ended up ordering some classic Lemon RXs, which have a much less compact antenna, but it would have to do. I decided to go with no pins for clearance, directly soldered connections only. For the weapon motor, I'm continuing with the Turnigy Multi-Star Viking motor. It is the same one from the initial revision, but it should still work. I'm pretty sure that it is continued, but I did stock up when they went on sale about a year and change ago, so I should have enough for 1 or 2 competitions. Powering that is the BL Heli brushless motor controller from Fingertech, which is small and highly recommended by other builders. And the battery is the same one used in Thwackintosh and Stompbot, a 120 mAh Galaxy battery. The next problem was putting everything together. I started everything together off camera and came up with this mess. Everything did fit, but it was not pretty. Everything was much too tight, and stuff was rubbing up against the weapon motor and the pulley. So I desoldered everything and replaced the wires with smaller wire. I also made sure to cut all the wires to exactly the right length. The weapon controller fits right here under the switch, and the drive controller fits right here above these 2 motors. The receiver fits right above that, and the battery nests between the 2 motors. There's very little wasted space, and what is left empty is a byproduct of both belt driving the weapon and also needing to allow space for the wheels to not conflict with each other. I'd done some driving tests before all the resoldering without the weapon motor connected, and it drives extremely well. While I don't have the original together, I do believe it drives better than the first revision, and much better than Thwackintosh. When it came to the weapon, I did need to test that. Obviously, a heavyweight bot can take off an arm, but even ant weights are dangerous, so I put the bot in a cardboard box inside of the unfinished bathroom in my basement, which explains the horrible lighting, and I closed the door, watching through this small mirror to break the line of sight through the crack in the door. I was also wearing eye protection. This is about as safe as one can get without having a fully fledged test box, which I do not have the luxury of. But enough on safety, back to the testing. I tried to spin it up, but it was super slow and stuttery. This was not good, so I swapped the belt out for a slightly longer one with little change. I did remember having to oil the belt on Blastwave 1 to allow it to slip, so I gave that a shot. It did work. It's for sure the sign of an underpowered motor, but throughout all of my looking, there aren't really any other motors that come close to this size. And I don't really feel like redesigning the bot around a wholly different motor, though I will need to do that eventually thanks to the Viking motors being discontinued. But with the drive working and the weapon working, the bot was functionally finished, which meant that it was possible for a final weight. The bot came in at 335 grams, a whopping 119 grams under the limit. Unfortunately, there isn't much I can do with that weight. I can't thicken up the top lids without moving the new wheels, which isn't an option, and I can't add a bigger drum without exposing more of the side and risking a hit, and switching to steel drum will add too much weight. To put that weight into perspective, I could basically throw Thwackintosh into the arena as a mini-bot with no modifications, and that would be perfectly within the weight limit. I might actually do that. I might design a new mini-bot, who knows. I could scale the whole bot up, but that's basically a whole redesign, and I kinda wanna see if the changes made improve performance or if it stays winless. Either way, the bot is basically finished. I could throw the bot into the box and compete with it right now if need be, so I feel pretty comfortable making this video at this point. I do need to figure out how to make the sick logo as a decal. I don't want to have to Sharpie a label like Blastwave 1. However, that's future me's problem. So if you want to see what this thing looks like in the box, be sure to subscribe, as I am for sure making a video on the next time I can get these things into an arena. If you like this, be sure to check out Stompbot 2, as it will be competing alongside this at whatever competition I attend. Also, the music for this video was written entirely by me. It's available for free from the links in the description, so go check it out. I put a lot of effort into it. Thank you so much for watching, and keep designing.